Good morning. Well, my name is Jorge Lamela, and I work as a postdoc in the Visual Optics and Biophotonics group of the Spanish National Research Center, the CIC. Thank you to the organizers for this opportunity. I will talk briefly about the multiphoton microscopy to study ocular properties. Our major interest in the VFVO group is the development of imaging techniques for the investigation of human visual system and the development of new vision correction alternatives. And we have applied this technology specifically to the understanding of the imaging mechanism of the optical system of the eye. Some of the main goals in this sense have been to obtain the three-dimensional variation of the refraction index to the eye lens or the dynamic response of the cornea to nerve-induced deformation. Advance of the understanding of the biological mechanisms and early diagnosis of ocular pathologies. For example, we have provided experimental data of the change in apex shift, corneal thickness, and anterior and posterior corneal radius curvature in an eye inflation model after corneal cross-linking, and evaluation new designs of refractive and presbyopic corrections, such as the effect of the airflow produced in ablation process in refractive surgery. That is why an important line of our research is based on imagining the different ocular components, such as the capsule, the cornea of the capsule to cover the eye lens. And the idea for our laboratory is to design and assemble an optical microscopy line to study these tissues, their structure and properties. Basically, we are designing an optical microscope that works alternatively as a confocal microscope or multiphoton microscope, depending on the laser that we use for the experiment. And all setup is served by pod configuration and only change the detection lines. In the case of confocal configuration, it's necessary to de-scan the signal to pass through a pinhole to have accurate resolution and reach to the detector, as long as in the case of the multiphoton detection line, it's not necessary to de-scan the signal, because given the principle of the technique, will be only multiphoton absorption at the focal point, and it's not necessary the pinhole to have accurate resolution, so you can place the detector close to the objective. It's possible to have a reflection configuration like this to measure the multiphoton excitation fluorescence, or a transmission configuration very useful for the second harmonic generation measurement. Our resolution parameters are the typical for a confocal system: half a micron for the lateral resolution and 6 times more for the actual resolution. We have obtained previously results in multiphoton microscopy in the cornea in collaboration with the University of Murcia to investigate change in the corneal stroma, and after cross-linking treatment in bovine and porcine eyes. And the second harmonic generation images show changes in the anterior corneal stroma, like the turn to the collagen regular patterns into random distributed structures, and this might be a consequence of the corneal thickness decrease as a result of the riboflavin installation. And in the same sense, we have obtained our first multiphoton microscopy image of the human capsule with our system, I want to say. And you can see in this image epithelial cells of a human capsule obtained from a capsulorhexis from a cataract surgery. And of course, well, our first wish is to complete the system and start to getting results soon. And the main wish we have is the study of the structure to the capsule to cover the eye lens to be able to simulate the accommodation of crystalline lens when they adapt the vision in intraocular lenses, and expand the collaborations we have with the Vascular Parliament Institute in Miami, and expand collaborations initiatives in the fields of high resolution imaging in the eye, collaborations that we have with the University of Murcia, with different groups from Boston, from this Madrid MIT consortium, and start new collaborations with groups interested in these topics, of course. Well, this is the contact information of the group. Okay, thank you.